I'm Hassan Jawahiri.
And I am Manuel Franco Sevilla.
We are professor of physics in the Department of Physics at the University of Maryland. We both run the LHCb group at the University of Maryland.
And in this cool building behind us, it's where we do our research. And in this beautiful poster over here, we have the Large Hadron Collider, or LHC for short. It is run by CERN, the premier high-energy physics laboratory in the world, and it's just outside Geneva, Switzerland.
So this very large ring of 17 miles long carries the photons in both directions at almost the speed of light, and they're smashed together at 4 interaction points, which you can see here in the picture.
Our group analyzes the collision data from this point here, where we have the beautiful LHCb experiment.
Which to be used to answer fundamental questions about nature, in particular the differences between the matter and antimatter.
But we also provide some of the hardware that is needed to read out the collision data. And we're currently working on producing the electronics that will read out all the data for this subdetector here, the Upstream Tracker.
That subdetector contains a number of silicon detectors, and these red lines that you see here are the trajectories of the particles going through the detector.
So let's see how we do this in our lab.
So here at this table, we assemble those DCBs. This involves taking this aluminum piece here, as well as the thermal gap or thermal paste over there, and this ensures properly cooling of the boards later.
And then we take the boards and place them over here to burn them in. Of course, this does not mean that we set the boards on fire. We thermal cycle them to try to stress the boards and try to find the ones that fail early. These boards have to survive under challenging conditions at CERN for 10 whole years. After we burn the boards in, we take them upstairs for the final tests.
This is the structure which holds the silicon sensors which measure the charged particle trajectories. The signals are read out by this flexible pigtail cable which is connected to this messy crate. The crate contains the DCB, which we saw downstairs already, which takes this data and then sends them via these optical fibers to the LHCb data acquisition system. With this setup, we can test all the functionalities of the DCBs, and when they are proven good and they work as we want them, we send them to CERN.
Hi, I'm Yi Hongsun. I'm currently stationed at LHCb at CERN. Once we receive the DCB, we will visually inspect and test them in the stress test to make sure DCB remain working after the shipment. After testing all the electronics, the electronics will be mounted on these frames. Along with all the electronics, these frames will be shipped 100 meters underground, and they will be running for 10 years for data.